So we're looking at question 3, and it says here that a particle is in equilibrium under the action of these 3 forces in newtons given by F1, F2 and F3. If they're in equilibrium, then you can write the vector equilibrium equation like this. And you know that that equals 0. So therefore, if you look at the top, so you can see A equals -4, and then put that into there. That's plus 12, so again, negative. B in this case is -12. So there are your 2 answers for question 3. Okay, what I realised was this is actually 2018, not 2019. So question 4, some mechanics. So we've got to get all the diagrams sorted out, so it's really worth drawing this out nice and neatly as well, and understanding what's all the forces and how they're all acting on each other, and that's really kind of very important. Okay, so first thing we're going to do is write in all the forces that we know and the tensions, etc., that we have. Okay, so we know there's a force going down here, and that's going to be mg, the mass times the gravitational pull. There's a tension here. Okay, so this is again Newton's second law. So the resultant force here, the resultant force is, if that is the positive direction, and we've got to assume that this is the positive direction. Okay, and therefore it's positive there. So it's going to be mg minus t equals mass times acceleration. So that's one equation there. And then what about up here? Well, we know that there is force down here for mg. We also know that there's a friction. It says it's a friction of 1/2 mg newtons, and there's a tension pushing it that way there. So again, that's positive. Okay, that's positive, so it's going to be T minus the resistance equals ma. So that's therefore the 4 times the mass as acceleration. So now there are my 2 equations. So what I'm going to now do is do a simultaneous equation between this. The key here is drawing it all out, working out what's happening with all the tensions. Once you can do that and you realize it's Newton's second law, you can do this. Okay, so what I'm going to do, I'm going to pause the video slightly, and then I'll wipe it off with these formulae and show how to do it using simultaneous equations. Obviously nowadays with your calculators, you can actually do this relatively quickly. So I'll pause it, redraw it out. Okay, now to find the tension, simply put it into one of these equations. Let's put it into, let's choose this one here. We can do that quite easily. So I know I've got mg, put that over to there, minus ma equals t. And so therefore I now can say a equals g over 10. So that's a 10th g. So that's g over 10th. And so therefore 1 minus a 10th is 9/10. So it's 9 mg over 10 equals t. There you go.